Good afternoon.
Good afternoon.
Welcome again to today's lesson. Today we will be discussing about what? Factors affecting what? Factors affecting energy requirement. Energy what? Requirement. Which are those factors that affect the energy requirement?
Sex.
Let's list them. One, sex is one. Two, age, correct. Three, body size, correct. Body size.
Activity and occupation.
Activity and occupation, it's nice. Activity and what?
Occupation.
Activity or occupation, it's the same thing, right? So when you say activity, don't mention occupation. Which one is the last one?
Lactation and pregnancy.
Lactation and pregnancy, correct? Lactation and what? And pregnancy.
Basal.
Then the last one?
Basal metabolic.
The basal what? Metabolic
Yes.
rate. I will start with the first one, which is what? Sex. We start with what? Sex. How do you describe or explain about the sex?
Males need more energy than females because they are more muscular, hence have more cells that inspire.
We speak about male being more muscular. Male are what? More muscular than what?
Females.
Females. Is that clear? Yeah, you know that, but we still say we have some females who are more muscular than men. Reason being,
Because they bodybuild.
they go for the bodybuilding and they do inject themselves with what? Steroid. But in our biology, we don't focus on that. We check a normal female. Right? A normal scenario of a female. Female should not be muscular. Female should be less muscular. Male should be
More
more muscular, right? So this male, being muscular, independent of doing a practice or not, so they'll do what? They'll require what?
More energy.
More energy, right? They'll require more energy. And this now, because they'll require more energy for what? Why do they require more energy? Because of their muscles, their cells will be actively respiring. Is that clear? When they respire, they will be releasing that what? Energy. And that is why the demand for this male energy requirement will be high as compared to what? That of the female. Oh, that is okay.
Yes.
That is one. Number two, we have what?
Age.
Age. We have age. How do we divide our age here?
Young children are actively growing, have many actively dividing cells, are physically more active, hence require more energy than adults.
We are speaking about the age of these persons, right? So we are speaking about the age of
Young.
young people. The young require what?
More energy.
Less or more, sorry.
energy.
More what?
Energy.
Energy. And reason for this one is because they have many what? Actively
Fighting cells.
dividing cells. When you talk about a young child, right? We speak about a young child eating more as compared to another, and that's what we see in our normal scenario, right? Children will eat more. Although they will be eating a small food samples at a time, but at the end they will eat more food. Right? And the main reason we are speaking about what? Why are they eating the small food? More food, sorry.
They require more energy to replace the energy that was lost.
Because, no. We are speaking about here, this point. Their cells are actively dividing. And because of the cells, we have something called cell division. That dividing of the cells is something called what? Cell division. So for these cells to divide, there should be cell division. In your form 3, you learn about process of growth. Is that clear?
Yes.
And the first process of growth is known as assimilation. From our digestion process, we understood about assimilation. We assimilate those nutrients the useful end products of digestion to the body cells, right? Then now when they assimilate to the body cells, what happens? What follows is something called cell division, and that's why now we are at the moment. Cells are divided. That's a cell division process, right? So after the cells divide, they differentiate. When they differentiate, now that's where our baby will do what? We will see our baby growing and growing and growing at a faster rate. Are you get the point?
Yes.
That is it. Then we are speaking about the elder or older people will not be doing what? They will not be eating much. They will not be taking much. The main reason most of their cells are already differentiated, so they don't require any more cell division. Cell division is at a lower rate. Is that clear? Then we have body size. Who will explain to us about body size? What happens in body size? You do comparison of what?
Yeah, a small bodied person requires more energy because they have large surface area to volume ratio, thus lose more energy than a person with big body.
Very correct. Is that clear? When you're speaking about body size, you do some things here. Surface area. We do some what? So we'll have large surface area and we'll have small surface area. But now it's to volume ratio. Here again it's to volume ratio. So when you speak about the large surface area to volume ratio, who are we dealing here? The small sized organism or large? Small sized organisms. Is that clear? Let me use a good example here. We have you have a rat and you have an elephant. You understand an elephant has a very big body, right? A rat will have a very small sized what? Body. So it will be having it's a small organism, that's a rat. The rat will be having a large surface area. And we are speaking about this small sized what? Organism will be losing a lot of it to the what? Environment. Is that clear? It's losing more of it to the environment. So it is lost in form of energy, right? So because it's losing now more energy to the environment, it will require to eat more to replace the lost heat or the lost energy. I get the point. We are saying the small sized organisms have a large surface area to volume ratio. And because of this, what happens? It requires to eat more food to replace the lost energy. Is that good?
Yes.
Then the opposite now will be the large surface area to volume ratio. This large surface area to volume ratio is like an elephant. The body size of an elephant, in terms of the exposure to the environment, much of its body surface is exposed to the environment. Less of its body size is what? Exposed to the environment. What happens with this one? It's not losing much of the heat as compared to a rat. Is that clear? And you'll be given an example of the elephant in terms of the body temperature regulation. That is, you are in the last topic of excretion. You'll be told an elephant will be flapping its ears twice as compared to the calf. A young one of an elephant is a calf, right?
Yes.
So that calf will be doing what? Flapping once. And the elephant will be flapping what? Twice. The main reason, body size of the young elephant will be exposed to much of the environment. So it will be losing it very fast. The other one is not much exposed. I get the point? So it will be losing the heat slowly. So we'll explain that in description. But for this one now we're speaking about, it has a large one. A large size, right? And because now of this one, it will not be losing too much energy. I think you have understood why it's not losing much of the energy. Its body size is not much exposed to the environment. Right? So because now it's not losing too much energy, it does not require to eat much because less of the heat was being lost. I get the point? That is what? Body size. Let's go to the occupation. Let's go to what?
Okay.
Occupation is what a person does. That is the activity the person will be doing. Who will tell us about occupation? Yes.
A manual worker requires more energy than a sedentary worker.
We have a manual worker and we have a sedentary what? Worker. We have two people here. We are saying manual and who?
Sedentary.
Sedentary. Manual worker is a person who is in the field. Maybe in Chengo.
A miner.
Yeah?
A miner.
In construction or even mining sites, right? Then these are the person
And doctor.
a doctor or an accountant who is just seated in an office. And swinging where?
A manager.
A manager swinging in a chair. Is that a seat?
Yes, a seat.
Right? So what happens to this person? The energy requirement will be very different. Is that clear? There is another person who is in the field working, using muscles, right? Will demand more of energy as compared to who? As the sedentary worker. So we are saying the muscles of this person who is working in the field manually, like carrying of brick, mixing of cement, what will happen to this person's muscles? The muscle cells has to assimilate more energy, more of those useful substances that we spoke about, like glucose. We respire, respiration rate between its muscles will be high, hence more generation of the energy. Is that clear? So the energy demand for this person will be high. So this person has to eat more food. The manual worker has to do what? Eat more food as compared to a sedentary worker. Is that clear? Let's go to which one? Lactation and what? Pregnancy. Which comes first?
Pregnancy.
Pregnancy comes before lactation. Is that clear? What's the main reason why pregnancy is coming in? So what's the energy demand for this pregnant woman and a woman who is not a pregnant?
The woman is pregnant requires energy for the fetus, while the lactating mother requires energy for the production.
I'm comparing now a pregnant woman and a woman who is not pregnant. Yeah, you're right. The pregnant will require more energy. These are the woman who is not pregnant does not require more energy as compared to a woman who is not pregnant. Is that clear? The main reason this pregnant woman requires some extra energy to supply for the development of the fetus. Is that clear?
Yeah.
As compared to the other one. Then when you go to the lactation now, still a lactating mother will require some extra energy still for what?
Production of milk.
For we're speaking about the development of the what? Milk, and also what? The release of those milk. Development of what? That is the secretion of those milk within the mammary glands, right? Then we have the secretion of those milk. So this energy requirement for this woman, she has to do what? To eat more. Is that clear? This woman has to do what? To eat more to replace that lost energy. Is that clear? Are we there?
Yes.
Then the last one is what? Basal metabolism or metabolic rate. How do we explain the basal metabolic rate? We will take us through that. We do speak a person who is at rest and a person who is doing what? Some strenuous what? Exercise. Basal metabolism. Even you are at rest when you are seated, right? You still require some what? Energy. And this energy required is for some maintenance of your normal functioning of your body. Is that clear?
Yes.
Your metabolism of your body. You'll be undergoing some metabolism, like which one? Gaseous exchange. You will again excrete. You are not excreting right now. Respiration will be taking place still. We have blood circulation, digestion. So because of this, what happens? There will be an energy required. Is that clear? And this energy required will be at a minimal rate. It's not that high as compared to a person who is doing what? Exercise. Is that clear? So the person who will do exercise will do what? Will require more energy because the muscles are more active. And this muscle demands more what? Energy. And because this energy demand is high, what happens? We are speaking about now the muscles will be undergoing some respiration to release energy. And the person will have to do what to replace the lost energy? Eat more. Anything we have to do to replace our lost energy is to do it, to eat more. Thank you very much. Have a pleasant day.